Hello everyone. In today's video, we will be solving a LeetCode easy question, that is minimum absolute difference in BST. Given the root of binary search tree, we have to return the minimum absolute difference between the values of any two different nodes in this particular tree. So there are few things that makes this question pretty easy. First thing, that is binary search tree. So we all know that the left subtree of binary search tree is always having smaller values than the one on the right side. So how this is going to be helpful? So the first thing, as we can see, if we simply exclude this binary search tree part from this particular question, so what will be the easiest thing to do? Let's see. So like if we are gonna see if we are having an array, suppose we are having an array where values are somewhat like 1, 2, 3, 4, 6, 9, and we have to find the minimum absolute difference. So isn't it going to be easy for us to find the minimum absolute difference when the values are somewhat sorted? Like if you are going to subtract 1 from 2, we know that the difference is going to be 1, and if we are going to do the same thing for 1 and 3, we are not gonna get the same difference. We are gonna get 2, which is greater than what we are getting from 1 and 2. So in this way, we can see if the data is sorted, this question is pretty easy. So that's the reason I was focusing on that in order traversal part of the binary search tree. So if we are gonna check out this particular tree, the in order traversal will be somewhat like this. Let's clear this particular space first so we can traverse the whole tree, and we will try to check what will be the outcome. So if I'm not going wrong, tree is somewhat like this. This is the right child. Okay. And there is one particular value. So let's assume it's 6. So if we are going to do the in order traversal of this particular tree, we know that we will be firstly going to root node, that is 4. But we are not gonna check out 4. We will check whether 4 is having a left child or not. We know it's having, so we will go to 2. Then we will again check if 2 is having a left child, we will go to 1. And as 1 is the leaf node, we will simply store it. Assume that we are having a array where we are storing all these values. Now as 1 is done, we are going back to its root node, that is 2. So we will store 2 as we are doing in order. So after left node, root node, we will be going to 3. So as we have already stored 2, so now we will be going to its right node, and that is 3. Now we will be going back to 4. We will be storing 4, and then we will be going to right side of 4. And this will be the sorted array that we will be getting after in order traversal. Now if we are going to check for the minimum difference between these values, we will be easily capable of doing this, right? We will be subtracting 1 and 2, and we will be getting 1. Then we will be doing the same thing with 2 and 3, 3 and 4, 4 and 6, and we know that the minimum difference will be equivalent to 1. So 1 will be the answer. But as we are capable of noticing one more thing, that whenever we are subtracting, we are only considering 2 consecutive values. So how we can just minimize this data storing step as well? Of course we can do that. Let's see how we can do that. So for now, just assume we are again going to traverse it, and we hadn't traversed before. Okay, that's easy to assume, right? Okay, So now if we are going back and we will again check 4 and 2 and 1, so we know we will be having 1 as our pre-node. You can name it as whatever variable you would like to, but let's assume the variable name is pre-node and we are storing 1 in that particular variable. Then we will go to 2. So 2 will be our current node, right? And the difference will be equivalent to 1. Now 2 will become pre-node and we are at 3, so 3 will be our current node. Again we will be checking the difference. Then again 3 will be going back to pre-node and we will be going back to 4, so it will become current node. Then we will be subtracting and storing the value. In this way we can see we only have to keep a variable to store the previous node that we traversed, and we don't have to store the values in a form of array, and in this way we will be capable of storing our minimum absolute difference. Now this 1, 1 and 2 are the values that we got by subtracting. We can store them as well in a variable, and we can simply maintain that variable with the minimum value. So this was the whole question. So this is how we will be traversing whole tree once. So our time complexity will be all about big O of n, and our space complexity will be equivalent to 1. But this is not going to be 1, as we will be calling this particular function recursively. We will be traversing the whole tree in a recursive manner. That's why it is not going to be 1, it is going to be big O of n. Big O of 1, I said just to let you know that we are not using any extra space, but big O of n will be the space complexity because we will be using recursive calls, so there will be a recursive call stack, and that in worst case can be equivalent to big O of n. So this is how this easy question that we can solve it in big O of n space and time. Just to save your time, I am copy pasting the code and we can go through it. And we can see that firstly we are defining a variable, then we are defining a pre-node variable, and then we are defining a function which is normal in order traversal, and we are adding one more condition that if pre-node is equivalent to none, then if it's not equivalent to none, then we will be checking for this difference, absolute difference, and we will be maintaining the minimum difference, and then we will be again replacing the pre-node with the current node, and again we will be jumping to the right node. So this was the solution. Let me just submit it and check whether this works or not. Okay, it works pretty well, we can see. And that's all for today's video, and we'll see you with the next one. Thanks.